everyone, Assalamualaikum. I'm Amor Andiay, the next reporter. So in this video, I will going to discuss about a multivariate analysis of variance, or also known as MANOVA, and the factor analysis. So let's start with the definition of MANOVA. So according to the definition, it is a procedure of comparing multivariate sample means. And as a multivariate procedure, it is used when there are two or more dependent variables, and it's often followed by significant tests involving individual dependent variables separately. So MANOVA stands for Multivariate Analysis of Variance. So we can guess that MANOVA is multivariate extension of ANOVA, which is analysis of variance. Just like a Hotelling t-square test, multivariate extension of t-test for means of two groups. So we can see here in t-test that we are trying to compare the scalar means of two groups, but for multivariate or the Hotelling's t-square test, we have three variables as the outcomes whose means we are trying to compare. Compared to t-test that we will have only one outcome who's trying to compare. So as for ANOVA, we are not trying to compare the means of two groups like the t-test because we are trying to compare more than two groups. So ANOVA can compare the means of infinite member of groups. So in form ANOVA, the multivariate extension of ANOVA, so instead of comparing infinite number of scalar means, we are comparing infinite member of vectors. So when we have mean vectors, we have three outcomes variables whose means we are trying to compare with the three means from other groups. So there are infinite number of groups. So in other words, ANOVA includes only one dependent variable, while the MANOVA includes multiple dependent variables. So a good place to use MANOVA is, let's say we are trying to compare the mean scores of students' grade, self-perceived happiness, and physical health from 30 students between four different Southeast Asia countries: Philippines, Indonesia, Vietnam, and Thailand. And these are the means of these three variables from a dataset. So we are trying to see if this means vectors are significantly different between these four countries. That's why we use MANOVA. So this is only an example, and this is not exact data, so don't be offended. So let us move on to the factor analysis. So factor analysis is a technique that is used to reduce a large number of variables in fewer number of factors. And it is a correlational method used to find and describe the underlying factors driving data values for a large of individuals. So like for example, in a set of variables, we have variable 1 to variable 6. A correlational relationship may be found between variable 1, variable 3, and variable 4. So this means that these three variables may in fact be only one value or factor. Accordingly, large numbers of variables may be reduced to only several factors. So consider this set of variables from variable 1 to variable 6. So the variable 1, variable 2, and variable 3 are in fact n one factor. So variable 2 and variable 6 are another factor, and variable 5 can be factor on its own. So you have discovered that variable 1, 3, and 4 are a factor, variables 2 and 6 are a factor, and variable 5 is a factor. So means this dataset is explained by 3 factors rather than by 6 variables. And factor analysis is often or referred to as data reduction. So once again, I'm Amor Andiay. That's all. Thank you.